Hi everyone, I got a request to make a video about a fundamental topic in discrete math and computer programming, and that's injectivity and surjectivity of functions. And so these terms sound quite complicated, but they're actually quite useful for programmers. Because imagine that you have a function and you want to return some output, but if you're not covering all the outputs, i.e. your function is not surjective, we'll get to that later, might not be the most useful function. So let's first take a look at these two terms, but in a really simple way. So I have a quick doodle up here, and what we're trying to show is that you have some function f, and it goes on some space script f to a different output space script h. All a function is really doing is if you have some like flowers and some honey cells, it's just saying whatever, give me a starting point in f, and my function is like a bee that's going to some output. And so what injectivity is saying is that for any two different inputs, you'll get different outputs. And what surjectivity is saying is that for any element in your output class, you just want to ensure that there's at least one input that's going there. And so the question my friend got in discussion is a bit more formal than that. And that's we're given a function f2 that is a mapping from integers onto integers where f2 of x is negative x over 2 if x is even, and f2 of x is quantity x minus 1 over 2 if x is odd. And so the first thing I want to check after looking at this function is it really mapping onto integers? That is, if x is an even integer, is negative x over 2 still an integer? Yup. If x is an odd integer, is x minus 1 over 2 still an integer? Also yes. So great. Let's start to analyze this function. And one thing is I drew up some code on the whiteboard here because I know that's sometimes really, really helpful in terms of let's just see it in code. So we have function f2 takes an integer and we expect it to return that integer. And so now we're going to test, is this injective? And so one way to do that would say, can I find two different integers that when I put them into f2, they give the same output. So let's start with f2 of negative 4, since that's an even number, x mod 2 is 0. That's going to be negative 4 over 2, which is 2. What about f of 5? It's not odd, or it's not even, sorry. So it's odd. 5 minus 1, quantity over 2, is 4 over 2. That's also 2. So we have a counterexample, which shows that f is not going to be injective. How about is f2 surjective? So we'll do this one a bit more formally and we'll say let little z be an arbitrary integer. And then can we find any integer input to f2 such that f2 equals z? And let's just imagine whatever this x is, it's going to be an even number, which would mean f2 of x is going to be negative x over 2, and we want that to be z, which would imply that z equals negative 2x. And negative 2 times an integer is still an integer. So in this case, we've got that f2 is clearly surjective because we found a mapping onto any arbitrary integer. And I hope that's helpful. Please reach out if you have any questions. Thanks so much.